in this class we'll talk about percentages. Okay, so basic idea of percentage. Say I ask you what is 20% of 130. Okay, so how do we do that? It's simply this, right? 20 times 130 upon 100, and this will give us 26. Correct? Now let us take a little complicated decimal for fractional calculation, or let's say percentage calculation. So I need to calculate, let us say 27.5% of 80. How do we do this? The normal way obviously is like you multiply 27.5 times 80 divided by 100, which unfortunately you can understand will take up a little bit of time, right, in calculation. It won't be as easy as the previous one. So is there an alternative we can look at instead of doing this multiplication? Anything that comes to your mind? All right, so look at an alternative. Okay, so when I'm saying 27.5%, can I think it of as 25% plus 2.5%?
Yes, sir.
So 27.5% of 80 is 25% of 80 plus 2.5% of 80. Now 25% of something means 1/4. So this is very clearly 1/4 of 80, that's 20. Now if 25% is 20, then 2.5% will just be divided by 10. So your answer is 22. Was this approach clear?
Yes, sir.
So instead of directly multiplying, what I'm basically suggesting is break the percentages down into manageable numbers. Like 27.5, you break it down into 25 and 2.5. Okay. So let's before we apply this, okay, so before we apply the shortcut, so 25%, if you don't know is 1/4, then it's back to the same thing, right? So we need to know certain values. Okay, so I'm going to write down the values which you should be aware of. So 50%, okay, let's write it like this. So percentage corresponding fraction. So this is 1/3. These are the most common values which you should have complete hold of. Okay, this is obviously 10%. Oh, so yeah, 1/10, I mean. So. Okay, now these are the main ones. Okay, so obviously if I ask you like say 60%, then you can think it of as thrice of 20%, so it will be 3/5. Right, 60% of something, you can just do thrice of that 20%, so it will become 3 times 1/5, so 3/5. Some other percentages which are useful are 5%, which is basically 1 by 20, 1 over 20, which can be thought of as half of 1/10. Okay, how we use these we will discuss. Okay, but let's first understand that these are the values which you should be aware of. 1% basically means 1/100th, or basically 1/10 of 1/10 in a way. All right, so now let's come back to our calculation. So let's say next I ask you for let's say 65% of 240. Let's say 65% of 240. Now how do we do this?
60% of
Yes, okay, plus 5% of 240. And now as soon as we have that 60%, we understand that okay, so we have 3/5, right? Because it's 20% is 1/5. So it's 3/5 times 240, and 5% you know is now 1/20th. So it is 1/20 times 240. So 3/5 would be how much? 144. Okay. So basically, how do you calculate 3/5? Okay, I'm coming to that. So you first multiply 3 with 240, right? You get 720. So I'm just calculating 3/5 of 240. First step you do 720 upon 5. Then don't divide. Okay. Multiply 2 again. 2 times 720 upon 2 times 5. So numerator becomes 1440 upon 10. So that's 144. See, dividing by 5 will be tougher than multiplying a 2.
Okay.
And the multiplication by 2 can be done orally, right? Like 72 times 2 is what? Like 144, obviously. And
Yes.
you have a 0 at the end which cancels out. So it becomes faster, okay? So these calculation techniques you should be like aware of. Like otherwise, what will happen is when you are solving questions and you come across these sort of calculations, the calculation will take up a lot of time, which you don't want to, right? If the calculation starts taking up time, then you won't have time to apply concepts and get to the logic of the question. Okay, so try the shortcut. So this we have got is 144, and obviously 1/12 is 12, so you have got 156. All right.
Okay.
Yes. Okay. Now let's say again, if I want to compare, let's say I want to compare which one is bigger. So quantity A is, let us say, 27.5% of 164, or let's say, let's take it a little difficult number. Okay, so 173.6, and quantity B is, let us say, 18.6% of 281.4. Now you have to tell me basically which one is bigger of the two, A or B.
Do we round off the percentage?
No, then there might be an error, right?
Okay.
Because if you round it off, this is 27, you make it 27.5, you make it 28, and 18.6, you make it 19. So that you have basically changed the actual values completely, right? So the new values that you have got might have the reverse inequality, right? Getting my point? Like,
Yes.
because you have approximated, yeah. So you can't do that. So there's a very useful technique here. See, this, what is X percent of Y? So we have been doing percentages. Simply X times Y upon 100, right? Eventually, that's what it get.
Yes.
Isn't it also the same as Y percent of X?
Yes.
Okay. So that means if you interchange X and Y from here and here, there is no change in the calculation. The value is the same. So what we do is for A, I change directly to 173.6% of 27.5. That's valid. Same thing. Now what I do is, after all, this is going to be multiplied, these two. So I divide this one by 10 and write it as 17.36% of, and multiply that 10 here and write 275. There is no change in this. Same thing. And now you see what is B is 18.6% of 281.4. So now B is, compared to a higher percentage value of a higher term, right?
Yes.
So B is greater. So you don't need to actually calculate anything, isn't it? You can just observe. So this is another very useful technique that you can interchange stuff. Okay, X percent of Y can become Y percent of X. And this helps in calculation as well as comparison values. Okay. For example, how do I use this to calculate stuff? Say, I want to find out what is the value of 28.4% of 240. Okay. Now 28.4% if I start taking, okay, now it's a complicated value, right? Even if I break it up, what will I do? 20 plus 8.4. But again, 8.4 is not going to help me much. So I have to break it again, like 20, then 8, then 0.4. Instead, what I straight away do is basically 24% of 284. I do the same thing exactly what I did there.
Yes.
Switched 240% of 28.4, divided 1 by 10, multiplied the other by 10. And now it is very simple. So this is, you can break as 20% of 284 plus 4% of 284. Now, how do we calculate 20%? You just multiply 2, right? So you multiply 2 with this, you get 568. So 56.80. Okay, that's the first one. Next, now if this is your 20%, then what will be 2%? It will be 5.68. And you have there 4%, so double of that. So don't need to again multiply 4 with 284. You can directly do it like this as well. Okay, that's what I'm trying to say mentally. So now you don't have to write that down. So you basically just multiply 56.8 with 2 and shift the decimal place. So what is 56.8 times 2? Quickly, 1136. Break it down, okay? So how did I do that fast? Okay, it's not that I have that memorized. Okay, so what I did was 568 when I'm doing 2 times. I said, okay, 56 times 2 is very easy to do. It's 112. And 8 times 2 is very easy to do. It's 16. Now add that. Mentally you add. Okay. 560 times 2 is 1120. 8 times 2 is 16. Add it. Or if you are, let's say, not comfortable with 560, you do 500 times 2. That's 1000. 68 times 2 is 136. And add them. Whichever combination you can do it. Okay. That whichever is convenient. My target is I will not do 8 to the 16 carry 1, then 6 to the 12 plus 1 13 carry 1. That I will not do, because that's a complete waste of time. Okay, it takes up a lot of time to calculate, because I have to multiply digits which have a carry. I have to keep in mind what that carry is, multiply the next digit, then add back that carry. So I'm not going to do that. So what I am doing is I'm breaking down the numbers. So 560. So you break, even if you, let's say, 68, you can't do 500 times 2, 60 times 2, 8 times 2. Break it like this. Okay, there is no problem. All right. So this will be faster than doing normal calculations. So we have 113.6, but then it is 4%. So 11.36. Now you add it up. Okay, so come out from the traditional multiplication way of doing questions, rather do multiplication or addition or subtraction, multiplication, division, anything in this way. All right.
Yes, sir.
Hold on. Anyone has any questions regarding this? Then I can repeat. Maybe with I can take some more examples if you want to. If you don't have anything, I'll assume that it's all okay.
I don't have any question.
Good. Okay. Now, so this still here we were doing. Okay. Okay. Fine. Good. So now till here we were doing direct calculation of percentages, like find out this percentage of this number, this percentage of that number, and so on. So that was more direct and easy. Now we are going to do the reverse. So what's the reverse? So if I ask you, A is what percent of B? Okay. So I'm asking A is what percent of B? For example, 20 is what percent of 60? So you're supposed to do 20 over 60 times 100. So that comes out to 1/3. So 33.33%. That's easy here. Okay. But what if you get some complicated values, and let's say you have got 123 or 123 is what percent of 319? Or let's make it a little more difficult, 379. Okay, 123 is, no, that made it actually easier. Okay, 319 is fine. 123 123 is what percent of 36319? Okay. Now, basically, I'll have to do what? 123 divided by 19 times 100. Not a very easy proposition, this one, right? Because normal division works. So 123, then you have that 319, and then you keep taking numbers. Okay, so a point straight away comes. Okay, and this becomes a 1230. Then it will not go 4 times, it will go 3 times. Okay, and you keep doing this. So not something which you want to do. So what's the alternative? So again, this will come in handy here. Okay, this will come in very handy here, especially this portion. Okay, so what I'm doing is take fractions of 319 and try to come as close to 123 as possible. Percent equivalence of the above fractions. That is your answer. Okay, so what I'm trying to tell you here is, so say simpler, take a simpler number. I want to calculate, let's say 15 over 40, 15 over 40 times 100. So 15 is what percent of 40? 15 is what percent of 40? So it's very easy, 37.5%, right? Like 15 over 40 times 100. So you will get 1500 over 40. So that's 150 over 4. So that's 75 over 2. And you get finally 37.5%. Okay. What we are going to do is not that. You are saying take fractions. So what did I say? Take fractions of 40 and try to achieve 15. So what fraction of 40 is closest to 15? Okay. So straight away I take 25%, one fourth of 40 is 10. That's the closest to 15. And I know that one fourth means 25%, right? Okay. Next, I have already achieved 10. I needed 15. So I need to add how much more? 5. So now I have to think of what fraction of 40 to take, which will give me 5, right? Obviously 1/8.
Yeah.
Now 1/8 of 40 is 5, and now we already had discussed that 1/8 means 12.5%. So this 10 and this 5 have given me 15.
Yes.
So
So
I just have to
57.
add up these two percentages.
57.
So 25, yes, and 12.5, isn't it? Now let's apply this in the earlier question. Okay, so 123 upon 319. So first thing you observe, this is starting with 100. This is starting with 300. So the fraction you should take is one third.
1/3.
And one third of 319 is approx 106. I am not going to consider that 106.3333 is not required, like 0.3 error when you are calculating as a division by 319 is nothing, right? 0.3 divided by 319 does not change my answer. Okay, I'll just ignore it. So 106 I've got. All right. Now I know that, so one third is 33.33%. So I've got one value. Okay. Now I need to add how much more? So I had needed 123. I have got 106. So I need to add 17 more. That's the first thing I decide. 17. Now how do I get that 17? Okay, so 17 from 319 right now looks a little difficult. Okay. So what's the alternative? Think of how to go about 17 here. Like what is half of 319? Now this is where your observation of numbers will come in very useful, right? So if I do half of 319, So basically 320 is almost 160, right?
Yes.
So instead of half, think of 1 by 20 or 319. So that's 16. And I already know that 1 over 20 is basically 5%. So I needed 17, I got my 16, right? So I need one more. Now, do you for any practical reason think that this one is actually going to be important in the calculation? Like 1 divided by 319, does it make a difference? No. So thus for practical purposes, I have got what I wanted, right? I got 122, I should be happy with that. So the answer is 38.33% is my answer, right? 33.3 plus 5. Now let us say that no, you are not very happy with this. You want to take that one also. So okay, so how do you consider that one? So you can see this is 100. Now this is not necessary. This step is not necessary because by the time you have got 38.33%, and you know that it is going to be slightly more than 38.33, you will be good enough to mark an option which is very close to this, slightly more than 38.33. That will be your answer. But now just saying that in case you want to get the exact feel. Okay, so what you do is you see 106, you need to get only one. So what you do is 106 is what, 33%. So 1 will be 0.33%. So just add 0.33 just to satisfy. So your actual answer is 38.66%. Okay. Check whether this method is clear or not. Like this method right now for you looks very difficult. Like you have taken so much time to calculate. But if you are good with this, you can very easily come to a conclusion that the approximate value will be somewhere around 40% or somewhere around 30% or 37, 38%. You can very easily come to that without having to open a calculator. It will be faster this way. Okay. And regarding the accuracy, if you actually try dividing by like in an actual calculator, 123 upon 319 is actually 38.56. So it's pretty good. Okay. The accuracy wise also it's pretty good. Was this method clear?
Yes.
How we did this? So I repeat once more. I started with 1/3. Why? Because this is 100, this is a 300. Let's say this was 389. I would have said that okay, this is almost 400. I would start with 1/4, not 1/3 now. Okay. So this is 1/3. So I started off with 33%. I got 106. I understood that I need 17 more. Because I clearly saw that 1/20th will give me a 16. So I am happy with that. 38.33, slightly more than that. That's your answer. Okay. This should be done very fast. Not like what we are doing now, but faster than that. So let's take another one, say 257 divided by 7, or let's say 913, something like that. So what fraction should we start off with?
One, one,
So you see
One third.
250, so it's almost halfway. 1/3 or 1/4, you can take either of them. Okay. Because if you take 200 by 900 is 1/4 almost. If you take 300 by 900 is 1/3 almost. So you can take either one. So let's start with 1/3. So 1/3 of 913 is 304. So now you have exceeded the requirement, right? You wanted
and four.
257. You have got, yeah. So now you need to subtract 47, right? Now, how do you get to that 47? That is what the main issue is. So you cannot directly get to 47, doesn't matter, okay? Break it up. So you see 900, you see
340.
440s. Yeah, you take 120th again, 5%. Sorry, you are saying something? You take 120th, like half of this will be 456. So that's 456 point something, right? So for almost 457, okay? So 128 will be 45.6, so that's 46. So you wanted to subtract 47, you have got 46 in hand. That should be like something which you are okay with. So it is 33.33 and now minus 5%. So your answer is 28.33%. And which is a pretty good approximation if you actually decide to calculate it in a calculator. Let me just check. So by the way, this entire thing, like how do you become good with this? So exactly do what I am doing. You randomly choose a value. Okay, randomly choose a value, do the calculation, verify in your calculator whether you have got the accuracy or not. If you have got the accuracy, you should be happy. That's it. So actual answer is 28.15. Good enough. Okay. Because I am right now just trying to figure out approximate value. I don't need a pinpointed value answer. Okay. So calculation methods of percentages, are they okay?
Yes, sir.
So there were two things which we discussed till now. One is direct calculation, the other is the reverse calculation. So all of you understand what you mean by percentage change, right? So when I'm looking at a percentage change, so what I say that if I say that the value of an item, say V, if increases by k%, then final value becomes, say, let's call it the initial value, and the initial value I and the final value F will become 100, sorry, 100 plus k% of I. And if it decreases, then final value will be 100 minus k% of I. All right, so it's an increase by 10%, so the value has become 110%. It's a decrease by 20%, so the value has become 80%. Okay, of itself. This is the basic rule. Now, when I have this 100 plus k percentage of something, so this means what? It's basically 100 plus k upon 100 times the initial value. And this part, if you simplify, you will get your formula which you usually use. Initial value multiplied with 1 plus k by 100. Okay, and similarly for here, the second case, you will get the same thing only with a negative sign. Is that fine? I think this is okay.
Yes, sir.
Okay. Now, let's take a calculation for this. Say if I tell you that the price increases, price of some item, okay, whatever, increased by 25%. So there are two ways in which you can write this down. One is you can say the final value is 125% of the initial. This is one possibility of one way of representing this. Or you can write it down as the final value is 1.25 times the initial. Because 125% means what? 125 upon 100 only. So that's 1.25. Or the other way of writing this down could be final value is now 25%, you know, is 1/4. So 1/4 increase means 1 plus 1/4 of I. So when I'm doing with percentage, I am thinking in terms of 100 plus 25 and so on and so forth. But when I'm doing with fractions, I'm thinking of 1 plus 1/4. Like 100 plus 25% is basically 1 plus 1/4 in a fraction. Okay. So finally it becomes initial times 5/4. Okay. So there are two ways in which you can represent this information. One is writing this, the other is writing this. In this case, obviously the second one is better because 1.25 is a 3-digit number. Like as in not a 3-digit number, it's a 1-digit number. But I'm trying to say is there are 3 digits. So if I have to calculate 1.25 into 246, basically I am now doing a 3-digit by 3-digit multiplication, which I don't want to do. But if I do the second one, which is 54 times 246, I have to just divide 246 by 4, which is so simple, 61.5, and I just multiply 5 with that. All right. So in this case, the second one is better. However, if I had, let's say, 12%, I have to write this. There is no other option with me because 12% does not have any corresponding fraction. 12.5 has, that's 1/8, but 12% you cannot write as 1/8. Okay, then it would be an approximation being done, which is not correct. Remember, in a quant question, try not to make an approximation. Okay, approximations are okay in you when you do data interpretation calculations in DI. That's fine. But in quant questions, the values usually are given in such a way that eventually when you simplify, you will find that everything cancels out. Like 1.12 is given to be something, you have to find the initial. You will find that that value they have given, though doesn't look like is a multiple, but eventually will cancel everything out with the 112 that you have here. And you will get a nice little value there. Now there, if you approximate this as 1/8 and write 9/8, then you will not get that exact value there. Okay. So it will actually become detrimental to your calculation rather than helping you out. So don't approximate as such when you do quant QA questions, unless it's a direct question like you have invested money in a bank at 3% rate of interest for 4 years. Now, what is the final amount? Then it's fine because the answer is itself what you get by calculating. But when you have a roundabout question where the answer is not the calculation directly, like you have to equate it to something and then get an answer, then do not approximate. So you got my point, right? When to approximate, when to not. Right. Okay. Now, next. So this is fine. Percentage change. Okay. Now let us say I tell you that you increase the price of an object by, let's say, 20%, and then again by 33.3%. So what is the net percent change?
53.3%.
53? No, 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 no. Why not? Because then I have to again understand the concept of percentages. Let's say this one versus, I now change the question to increase the price by $20 and then again by $33.33. And what is the net change? Not percentage, but
Oh,
just net.
sorry. Then it will be 153.3%.
No, 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 no. No, 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 wait. I'll explain. Wait. Now, this second one is correct. Okay, this is correct. But the first one is not 53.33. Why? Because when you do the 20% change, it is on the original value, right? Now, when you do the 33% change, it's not on the original value, right? It is on the increased
Oh,
value.
okay.
So the increased value is being changed. That means the result will be greater than 53.33, not 53.33. So you can say for certain that it is greater than 53.33% because you have increased 33% on a higher value. So the effect will be higher than 33.33 on the base.
Yes.
Okay, so when you're looking at net percentage change, we are now trying to calculate with respect to the base. So the effect will be higher. So now the question is, how do we calculate? Okay, so method number 1. Okay, so understand this diagram which I'm trying to draw. So Let's say this is your object whose value you are going to increase by 20%. Okay. So after the first change, this value was there and 20% of itself was added to it. So this is its value, right? Whatever the value was, that rectangular strip is the added because of 20% increase. Now we are going to increase by 33%. So the original value, that's the original box, and that rectangular strip, both are present. Now I am going to do what? I am going to increase that box by 33%. So I am getting another value, correct? And then at the same time, I am going to increase this rectangular initial strip also by 33%. I will get another small value. So what are the things which I have got? I have got a 20%, I have got a 33%, and I have got something extra here. Let's see what is that. So this is 20% of the initial, where this is the initial, right? Now the second rectangle is basically 33.3% of the initial, and the third strip is 33.3% of 20% of the initial, which basically becomes 33.3 times 20 upon 100. Okay, or rather let's put it like this: 33.3 upon 100 times 20% of the initial. Is that fine? So what is the net addition, net increase? 20%, 33.3%, and 33.3% of 20. So that's 33.3 times 20 upon 100. This is your formula. So what is the formula? X plus y plus xy by 100. Okay. What did I just now say? So if I increase the value, so increase the value, initial value by x% and then again by y%. So my net percentage increase is x plus y plus xy upon 100%. Clear?
Yes.
Over here, would you prefer doing this, or would you prefer doing something else like what I'm showing now? So what I'm showing here is, first you have increased by 20%. So first step you had I, next step you became 6/5 of I, right? Why 6/5? 1/5 increase. 1/5 increase means 1 plus 1/5. So 1 plus 1/5 is 6/5. Now on this, you are going to have a 33.33%. That's 1/3 increase. So it will be whatever it was, I times 6/5. On that, with that you multiply 4/3. So what do you eventually end up getting? 6/5 times 4/3. So that's 8/5. So that means you can say that now once you have got this, there are two ways of proceeding. So one, you can say that the increase is 3/5 since, sorry, since 1 plus 3/5 is 8/5. Because when you were looking at fractions, that's what we were doing, right? 1 plus how much? And 3/5, you know, 60%. Because 1/5 is 20%, so 3/5 is 60%. So that's your answer. Or alternatively, you could have done, so it becomes I times 1.6, which means 160% of I, which means increase is 60%. Is either way clear? Now, which one do you think is a better way of doing it? Is using the formula, which is
Using the
written in
formula.
no. In this case, it's not the formula, because of this value. 33.3 times 20 is a bad calculation. Not very bad, not very bad, I agree, but it's not a very good calculation either, right? So here it makes more sense to do this because I will be able to do this in, let's say, a fraction of the time it will take to use that formula to get it. But so when do we use the formula? Why did I even tell you the formula? So formula you will use when you have some percentages whose fractional equivalents are not known or they don't exist. Like you increase by 11% and then reduce by 7%. What will be the net value? Now, how do I do fractions with this? I can't because there are no fractions. So I will use the formula there. Okay. So I say increase by 11% and then decrease by 4%. So my result will become, using the formula, 11 plus negative 4 plus 11 times negative 4 upon 100. So simple now. 11 minus 4 minus 0.44. So 6.56. This one I cannot do with fractions because they don't exist. If I try doing with decimals, I would have to do alternate method, that it has become initial value times 1.11 times 0.96. This multiplication I would definitely not try to do work out. It will come out to be the same answer, 1.0656, and hence I will say that it is 6.56%, but I will not do it. I would prefer doing formula. So is this clear? Like when to use the formula and when to not use the formula? It entirely depends on what are the values given to you. Is that okay?
Sir, can you explain the second method?
What, this 1.11 times?
Uh, yes.
So 11%, this is, I am going back to this, what I had started off with, this basic.
Oh, no, not that one. The increase by 6 by 5. Um, the second method that you used. I into six
This
by
one, right?
five.
This one you are saying?
No.
This one?
The one towards the left.
This?
Yes.
Okay. 8 over 5 I calculated is 1.6.
Okay.
And then I said that it means 160% of something, right?
Mm.
Because when you're dividing by, when you're thinking of percentage of, then you divide by 100.
Yes.
So after dividing by 100, I have got a 1.6. So it must have been 160%, right?
Mm.
So 160% means it increased by how much? 60%.
Okay.
Yeah. So, oh, someone has joined just now. Okay. Never mind. All right. So this is what the idea of the percentage change is. Okay. So I am not going to do anything else beyond this. Okay. So I have till now, what have I discussed? I kept it simple here. So I have told you what is calculation. So how to calculate a percentage of something, how to calculate like this is what percent of something. So that calculation when you have a division. And then I have discussed about what do you mean by percentage change. So now there are a couple of other things also in percentages. Okay. So like successive percentage change we have discussed also. So that also we have discussed. So there are some other concepts also, but like percentage point change and so on and so forth, but that will keep for some other time. Okay. So this is the basic, like basically if you think in this way, that if you are through with this, like you have understood this entire thing perfectly, then almost you can say 90% of any question that comes in CAT you can do based on percentages. Okay, almost 90% can be done very quickly. For the remaining 10%, you can also do those, but you will have to do the long way. So for the shorter approaches for those remaining questions, we will take up some other time. But this is the major part of percentages, whatever we have done. Okay, just keep things very simple. Don't make it complicated. Like don't there in the books you will find that there are a lot of formulae will be given. Okay, so this happens, then you do this percentage, then this divided by this. If this happens, then do this instead. So don't memorize that. That's not going to help at all. You will eventually become more confused and end up using the wrong relation in the wrong place. So keep things simple, know the basic logic. So percentage change means what, how to calculate the percentages, and what do you mean by successive percentage change, and when to use that formula, when not to use that formula also, both. That's important. Okay, so you have any questions? Those who have joined right now, sorry, we are just closing up the class. We are done with the concepts. It was a 1 hour demo basically. Okay, so I'll just tell you something about our institute. I think someone who had called you must have told you as well. So over here, like this is how the classes will be. So right now, those of you are like all of you are near about living in Calcutta only, right? So you right now, since the lockdown is there, so we have moved our entire classes online. Once the lockdown gets over, so during this period, if you decide to join, we'll do the classes online itself, okay? So that you don't lose up on your preparation time. And now once the lockdown gets over, so whenever it gets over, so that depends on the government instructions, so we will transfer all these classes, like the entire batch, like all of you will be doing classes offline in a classroom program only. So we'll reopen our centers and everyone will be shifted to a batch. We will be given a batch, assigned a batch. We will be doing classes in that batch only. We'll give you all the study materials, hard copy and everything. For the time being, we will be just giving you the handouts with which you like solve questions at home and practice. Okay, so the handouts, all of our handouts are pretty good. Like we have ourselves made the handouts. They have pretty tough questions and simple questions also. It's a mix, so it's exactly as per CAT standard. So that itself will be a very good preparation. For the time being, you can keep practicing from there. Also all the classes that you do online, you will be given video recordings of that. So right now when you are doing online, you don't need to waste your time in taking notes and stuff. So you should mainly focus on understanding the concepts, because you'll anyways get to see the video as many times as you want. Okay, so these are the things. Plus regarding our classes, who are taking it, so my name is Sujay Datta. So Cubics is my institute. Like I founded Cubics 3 years back. So last 3 years we have got a lot of good results, like IM calls and everything. So you can check our website. I'm just putting it up on the chat itself in case you are not aware of the URL. So you can check the URL, see the student feedback and reviews also. From there, I have personally taken CAT almost 9 times now. Every year I sit for it. I have got 99.99, I think, last year in quant. Overall, I always get above 99. Last year, I think, was 99.6 or something like that, 99.7 maybe. So all our other mentors are also similar. Like there are people who have got 100 percentile in quant. Okay, most of our all our mentors in fact are more than have a decade of experience in teaching it. So we have Sanjay sir and Sudeshna ma'am will be taking your verbal classes, so with more than 10 years of experience. So this is roughly our institute profile. You can see all of that in the website itself. Okay, so you have any questions?
No, sir.
Okay then, all right, nice
Thank you.
talking to you. Yep.
It's nice talking to you as well. Thank you for
Yep.
your time.
Yep. Bye bye.